Today on How It's Made. Pro hockey sticks. The puck stops here. Bronzed baby shoes. We take you through the process, one step at a time. Treadmills. We'll bring you up to speed about how they make them. And handheld computers. Computer processing unplugged. But first, today's cutting-edge ice hockey sticks are made primarily of graphite, a strong yet lightweight material woven from carbon. Professional hockey players have them custom-made, with the curve and angle of the blade tailored to precise specifications. You'll want to stick around for this one. To construct the stick's hollow shaft, 15 sheets of graphite are layered, each in a different direction to make the shaft uniformly rigid. Heat-activated resin molds the layers together. This machine, called a flex tester, measures how much force it takes to bend the shaft 2.5 centimeters. If the force is within a certain range, the shaft has the correct degree of stiffness for that model. The blade starts with a plastic core. In the center, there's a piece of hard foam wrapped in graphite. It absorbs the impact of the puck. Later, the core will be molded to the shaft, but for now, it's glued and clamped together. When the glue has dried, the core is covered in a graphite sock. The sock's fibers run diagonally. The fibers of subsequent layers run in other directions, building a combination of crisscrossed fibers that creates uniform stiffness throughout the blade. Now the core goes into a glue applicator. This heat-activated plastic resin permeates the graphite. Once it cures, it will fortify the material. On the next two layers of graphite are strips. On one, the fibers run vertically. On the other, they run diagonally. They're stiffer because they've already had a resin application. They run through the glue applicator and go onto the core. This is how the factory builds its graphite blades, whether mass-producing amateur sticks or making a few special order sticks for a professional player. At this point, retail sticks head into large-scale automated production. The professional sticks continue to be made by hand. Initially, a customized wooden mold is produced for each player's stick, and it's given an identification number to prevent mix-ups. This two-piece mold is installed on a press. The press shapes the blade to the player's precise specifications for the face or vertical angle and the curve. This molding process also compresses the graphite layers into a single unit and permanently bonds the blade to the shaft. The plastic bag over the blade prevents excess resin from oozing over the press. With a router, the blade is profiled to a specific shape. Each player orders his own personal template. It can be any shape, as long as it abides by the Hockey League's regulations. Maximum curve, 19 millimeters. Maximum height, 7.6 centimeters. Maximum length, 30 centimeters. Now the blade gets a good sanding and a thorough buffing. The blades are dipped in urethane, a colorless coating that fills in tiny imperfections on the surface. Once that dries, a machine sprays silver paint at the base of the shaft. Finally, another coat of urethane to seal and protect the paint. For the retail market, this company mass produces 6 models of graphite hockey sticks in a right-handed and left-handed version. They all have the same blade shape, but different curves. You can peel off the removable model name and write your own name on the shaft instead. It's not nearly as personalised as a made-to-order model, but at least you won't go home with somebody else's hockey stick by mistake. The pitter-patter of little footsteps is a welcome sound in any household. But before you know it, children have grown up. Bronzing baby shoes is one way to preserve the memory of those early years. The tradition was started back in the 1930s. We look at the process step by step. In these shoes, a child learned to stand on his own 2 feet. His baby shoes have joined piles of others. They're about to be preserved forever. Information about the shoe's owners is recorded, including personal details for engraving. A tracking number is assigned to each pair. Without it, some shoes might not find their way back to their owners. That number is stamped onto insoles. There's a special coating on the insoles that will prevent the metal plating from sticking to them, so this number will be visible throughout processing. The insoles are stapled down. And then the shoes are dipped in a special formula. It chemically seals them and will also help stiffen them as they dry later. But first they're hung to allow excess liquid to drip off. Each shoe is stuffed with plastic to give it shape. A rolled plastic form is pushed into each shoe to complete the shaping. The laces are tied and the bows are positioned flat against the shoes, so they won't break off during the rest of the process. As an extra precaution, a rubber band is wrapped around each bow and then glued down. With the shaping plastic removed and the shoes dried and stiffened, holes are drilled into the bottom of the soles. This will allow them to be hung on prongs later during plating. But before that happens, a mix of water, copper and other ingredients is stirred. A rack full of baby shoes is carefully submerged into the coppery liquid. This isn't the final coating, it's a key preparation step. It makes the shoes conductive so they can be electroplated. The shoes are hung to dry, and a little more of the liquid is dribbled onto them to cover any bare spots. The finish is allowed to dry for a couple of days. Then, they're lowered into the electroplating tank. An electrical current runs through to the shoes, attracting copper in the tank to plate them. Using a special polishing wheel, the bright copper finish is scratched. This prepares them for the next step. A black finish is sprayed onto the shoes. And then it's wiped off, rubbing some into the crevices to give them an antique appearance. Next, they're sprayed with a protective lacquer. You can still see the identification number clearly on the insole, so they haven't lost track of the owner. The engraving plate is attached onto a wooden base, and the shoes are screwed onto it. Now they won't be going anywhere, except down memory lane. And it seems there's no end of bronzed keepsakes that can also take you there. From cowboy boots to burgers on a bun. I remember that one. Coming up on How It's Made, treadmills. To make them is no walk in the park. And handheld computers, high-tech gadgetry that fits in the palm of your hand. See you after the break. Welcome back to How It's Made. Treadmills were invented back in the 1800s. Farmers put animals on treadmills to power butter churns and threshing machines. It wasn't until the middle of the 20th century that people started working out on treadmills. And as a fitness concept, it's been a runaway success. In these high-tech treadmills, computer processors assess your level of fitness and plot your workout program. To make one, they punch holes in aluminium frame side pieces. These holes will be used to attach other parts. But first, they weld joints to the side pieces. And they weld brackets onto the platform that will hold the treadmill's motor. They position the platform between two aluminium side pieces and screw it into place to complete the frame. Next, they attach the elevation mechanism. This piece will raise the treadmill belt. They fasten wheels to the frame that will allow the treadmill to be rolled away for storage. They turn over the treadmill frame and work on the underside. They attach brackets for the rollers that go inside the belt. Then they position the belt and deck over the frame. They slide in steel rollers and attach the drive belt. They bolt a large shock absorber to the drive motor to dampen its vibration. They install a strobe disc and then place an optical sensor over it. With the help of this sensor, the strobe will monitor the motor speed 16 times per second. They mount the drive motor for the treadmill belt on a special platform and bolt it into place. At this point, they attach one of the computer boards. It receives information from the optical sensor about the treadmill's speed and relays it to the computer in the control panel. This will ensure that everything is in sync. Here, they slide a protective casing over the framework. They cap the ends, then turn over the machine once more to install the mechanism that allows the treadmill to be folded up when the workout is over. They screw a plastic cover onto it to protect the bottom. And it's over to the control system. They stick the control membrane onto the plastic housing and attach a safety switch to the back. Then they install the treadmill's other computer board in this housing. They plug a wire into the safety switch and install a receiver to pick up the runner's heart rate. They secure the handlebar assembly to the control housing and plug in the upper circuit board. Now they close the back of the control system and it's time for the two assemblies to come together. They connect the upper and lower computer boards so they can communicate. And then they give the treadmill a little test run to make sure it's on top form. They put it through a range of elevations and check the belt to determine if it's running in the middle. They adjust the belt to center it a little better. The treadmill has passed inspection. So they wipe away their footprints and press the brand label onto the hood. They lower the hood onto the motor, and now this treadmill is ready to give you a good run for your money. Go on, faster! Handhelds are rugged computers designed for workers on the move. They're used by delivery drivers, policemen, and in warehouses. They process data in virtually any condition, from bad weather to rough roads. So even though you're in the field, you're still plugged in. From scanning barcodes to reading parking meters, handhelds provide information on location. They start with the keyboard electronics panel. They test each contact for conductivity. Then, they transfer the tracking number from the electronics panel to the inner casing, so it will be visible if it needs servicing. They glue the panel to the casing with silicone for a waterproof seal. The rubber keypad goes on next. Then, they glue a protective plastic plate over it. Next, they cut a silicone liner to the size of the computer screen. It will help seal the unit, preventing water and dust from getting in. They place the liner in a bracket behind the screen, and then use this jig to align the screen to the computer casing. A dab of thread locker glue to the screws helps to hold it all together. The top casing for this handheld computer is now assembled. They move onto the back casing and install a speaker. They apply a layer of silicone to a circuit board assembly, again to resist water and dust. This circuit board assembly goes into a hole in the back casing. It will allow the unit to communicate with a central computer. In the next step, they wire the speakers to the circuit board, and now the handheld has a sound system. More silicone on these connections. Then they install triggers for the scanner, one on each side. They install a liner on the door for the memory card compartment. Then they run the top assemblies for 3 hours in extreme temperatures. Once the inner workings have been completely installed, they attach the top assemblies to the bottom ones. They tuck the battery pack into its compartment and install the end cap. It has an antenna for wireless communication. Now, they install a smart card reader because this particular handheld computer will be used for security checks on personal ID cards. They test the laser scanner, then activate security software, which reads fingerprints, allowing this handheld computer to do security or criminal checks on the spot. When an unregistered person presses a finger onto the print reader, this is what happens. Of course, mobile computers are designed to return to a home base, where they upload information into the main computer. But first, randomly selected units get roughed up in a series of tests. They toss this unit into a tumbler, and it gets thrown around. Then they drop it from a height of 2 meters. They plunge it into a tank of water. In the real world, things can be even tougher. This computer ended up in a fire. And this one was run over. But even when it seems they've been completely destroyed, information can still be salvaged. Here they transfer the memory board from one of the wrecked units to an undamaged one. They hook it up to the central computer and retrieve the information. After all, these units are really all about the facts. So, whether you want to be a hit with your teammates, or want to walk down memory lane, or simply walk from A to A, now you know how it's made.